I'm gonna record every lecture, you're gonna post it. So this is ECE 101. If you're not here for ECE 101, you can slowly go to the walls and then get away if you want. No one's gonna judge you. So this is basically your introductory to electrical engineering class. It's your first look at what you're gonna have to do as an engineer, as an engineering student here at CSUN. This is my now third time teaching this class. I'm losing count already as we go along through it. I've revamped it quite a bit. You probably have like no preconceived notions of this class, so it's a good thing. In the past, it was really an easy class in the sense that it was just, you come in, learn how to study, you're out, you get an A, you move on with your engineering curriculum. So the way I changed it is kind of a couple ways. So the first thing is that I did make it a little harder. And so I don't mean to like try to scare you. People do fail this class, not because it's my fault, it's because they don't come to class. And I think they kind of come with the notion like, oh, it's a 101 class, they want us to succeed, and we do want you to succeed. But if you're not gonna do anything, then like I'm gonna give you an F, right? And I'm laying out the actual syllabus for that. So there's percentage points you can get to get your A or whatever you want to get, but it's not going to be a cakewalk in that sense. So if you have that notion already, please take it out of your head now. But with that said, it should be a fun class. So I've also revamped it where I give you a project, and the project is basically this. And if this doesn't get you excited, then I don't know what will. I did find these cool things on Amazon. So in the past, I've actually had students do this electric ukulele / like mini guitar. We would do it from scratch, but I kind of got lazy with the mechanical part of it. So on Amazon, and actually we have funding for this. So I got funding from CSUN, so you can start your love affair with CSUN now because CSUN is pretty great. They actually funded us to make these things. So you're gonna get one of these kits. It comes with a ukulele and the actual all the parts basically, and it also comes with strings. The knobs, the strings are pretty horrible. So if you want, you can use your own money to buy your own nylon strings or use the ones you're given. These are free. So it really depends on how cheap you want to make it. But this is given to you. It has also the frets. And what you're gonna do is this is an electrical engineering class, not a music class. And I'm also not a musician. So I'm gonna play this thing for you once I'm done with it. And we're all done with it. And you're gonna see that I'm not a musician. But I also have these cigar boxes, and I don't smoke, but I do have them. They're pretty cool looking, right? And what you're gonna do is you're gonna make that ukulele. It's basically just an acoustic ukulele, right? So you just play it, but you're gonna make it electric because we're electrical engineers, right? We're gonna basically electrify it, and we're gonna basically make a little speaker that allows you to like change the volume, change the tuner, like basically what is that? Like how do you do that? We'll learn all that stuff. As a part of the speaker, you're gonna get not this cool speaker, because this is the one I bought. You're gonna get a cheaper one. You're gonna get a bunch of electronic components and a schematic, and you're basically gonna get the box. We're gonna have to drill some things. We're gonna have to make a circuit board, and you're gonna basically, at the end of the day, you're gonna have a ukulele, which you can paint whatever way you want with a speaker, and you're gonna be able to play this electric ukulele. Okay? Now here's the sad part about this whole thing is we didn't get that much money from CSUN. So you're gonna have to get into groups and you're gonna have to fight about who's gonna keep the ukulele, and at the end of it, you're gonna keep it. It's not mine, but I will record you guys and put you on a website so we can show like how cool ECE 101 is compared to other 101s. All right, so that's that. I wanted to get you excited right away because I think it's pretty cool. But yeah. Also, as we go along, if you have any questions, feel free to just raise your hand and ask them. I don't bite. Don't be intimidated by me. You shouldn't really be intimidated by the professors. You should respect us. We're older than you. And now I'm realizing that I'm really older than you guys. You know how to look it. But as I'm here longer and longer, I'm like, oh, I'm getting old. But yeah, so we're gonna go. So the first week of this is we're gonna go over basically like soft skills. So like how to study, what electrical engineering is, how do we learn as human beings. It's gonna be kind of weird. You're gonna be like, why? This is not a psychology class. I didn't sign up for that. But I think it's really important because it's gonna allow you to basically reflect on how you actually study. Some of you are coming in as like the top in your class, and that might be a rude awakening because there's a lot of people that are really good at what they did in high school. Some of you, are just happy to be here. That's fine. It's gonna be tough for everybody. I remember when I was coming out of high school, I wasn't top of my class, but I certainly was like up there. And the first semester was real tough, really tough. I got my first F in my first exam. That's how tough it was. And after that, it was an uphill battle, and I ended up getting a decent grade in the class. But that was a shocker, right? Like, I thought I knew how to study. I thought I knew how to do everything. I was so smart. But, you come here and you're thrown a lot of stuff. It's also the first time that, you're treated as a real adult. So, like, we're not going to basically baby you. We're not going to micromanage you. You have all this time. You only have class like certain number of hours in a week. And you can, go back home and do whatever you want after that. But you're gonna find out that time probably should be spent studying or doing something productive for your classes. We'll get to all that later on. So let's get to the course. So I actually posted the syllabus on Canvas and I made it public. So does anyone know what Canvas is? Yeah, okay. So Canvas is basically like the learning management system. Just a fancy word for it's a website that CSUN uses to basically post everything for the class. So it's like your go-to hub for like all the lecture notes. So like these lecture notes are all gonna be on Canvas. So if you wanted to download them and you wanted to write on them or whatever, you can do that before class. The syllabus is also on there. So who knows what a syllabus is? Did y'all get syllabuses in high school? I don't recall if I got a syllabus in high school. But it's basically like, it's not a contract, but it's basically like a summary of how this class is going to go, right? So it has like, how do I break down your grade? And the one thing that I I'm very proud of as a professor is that I actually am pretty transparent with how I grade. And so you know exactly what you're going to get if you just calculate it, right? You're going to be given back your graded work. You can calculate how much percentage of that is, part of your actual final grade, and you can predict what you're going to get. And we'll get to the actual grading stuff later on because there's something else I want to mention. But the syllabus has all that stuff, and it also has all the information like where to contact me. My office is JD 3525, so that's up here. Let's go up a flight of stairs, and if you make a left as you get out of the stairs, I'm kind of towards the elevator, towards the very, very end over there. Feel free to come by anytime. I'm usually in there. Usually lonely, but it's fine, doing other work. But the days I'm gonna have my doors open, so my doors will probably be closed just because I got to get work done, right? If I had them open, students would always come in, which is fine, but I also have to grade and all that kind of stuff, right? But so the times I'm gonna allow for like just open door, you come in whatever you want, you don't have to ask specific questions, are Mondays and Wednesdays, 11 to 12:30. So basically after this class, you can come in to the office hours. If you have questions on the quizzes, anything regarding any of the homeworks, whatever it may be, you basically can see me at that time. If that time doesn't work for you, if you have like a class after this class, then you can basically email me an appointment and we can meet another time if you want to talk. But those are my office hours. This is my email. I always say every semester, I'm making a concerted effort to basically answer my emails much quicker. I've started off on a good note this semester, but I do get a lot of emails every day. So if I don't respond to you within like 5 minutes, even a day, I'll try to get to you as fast as I can. So this is a description. So it's basically a freshman orientation course to get you acquainted with electrical engineering. So it's kind of weird the way the schedule is on on your whatever you see on my portal or whatever it is. It says like lecture for 25 minutes and then like lab for like the rest of the like an hour and whatever it is. We're not gonna do it that way. It's one class. The way it's gonna work is we're gonna go through some actual content. We're gonna have some activities, whether it be like you're actually working out a worksheet and I'm walking around and you're in groups. Or it'd actually be a lab where I actually give you a lab to do and you have your partner and you work on it. Or it could be part of the actual project with the ukulele. So it'll change depending on the way the semester is going, but that's how it's gonna go. It's not gonna be rigid. Okay, so you're probably thinking about the book. Who has gotten the book? Okay. It's not required. It's actually a good book. I think it's okay. But we're not going to use it in this class. We're actually not going to use any book, really. I'm going to base some of my slides off of some of these books that I'm going to talk to you about, but you're certainly not required to buy it. And the one that was on the list, you don't actually have to buy it if you don't want to. With that said, I would keep it. I mean, how much was it? Like $20? Give or take what? $5, $10? It was $25. Okay, I mean that's not too much, but you know, if you want to return it, you can go ahead and return it. We're not going to use it, so there's no like homeworks out of there. I don't even really have any content. I've read the book. It's just I don't feel like it's going to be as useful because we're going to take more of a technical approach to this class than a soft skills, which is that is. But the one I do recommend that I do base my lectures off of is this one, Exploring Engineering. So I do base some of the content off of this book. So definitely take a look at it. It's general engineering, but there are a lot of chapters on electrical engineering and computer engineering as well, and units and all that kind of stuff, and how to actually problem solve. We're gonna basically use that as well. So the next slide is another book. So this one is if you're a hardcore electrical engineering hobbyist or nerd. This one is, it's actually relatively cheap. It's about $10 to $15 on Amazon. It's a big fat book, and it just shows you many different concepts of electrical engineering for a hobbyist. So you don't even have to have an electrical engineering degree to read this. It tells you what's a resistor, what's a breadboard, what are switches, what are they used for, what's a capacitor, what is it used for. It has a lot of cool diagrams, a lot of really easy to understand diagrams. It has some equations, but the point of this book isn't to basically teach you the equations. It's to teach you what are the different components that you can use for a digital circuit, for a computer, or whatever, and learn about them. It's very, very easy read. It is a big book though, but I think it's a really cool book. If you want to take a look at it in my office, I have one, a copy in my office. If you want to see what it looks like, it's a good book to just have around. I use it once in a while. It has these resistor tables of like the color codes and all that stuff, so I think that's pretty useful as well. Any questions? Okay, so grading. So this is probably what some of you are anxious about or worried about in this class. So let's just get straight to the nitty-gritty. So quizzes, you're gonna have quizzes every week, almost every week. There's some weeks where we'll skip, but it's gonna be either on a Monday or a Wednesday when we're scheduled to have class, and it's gonna be random. And it's gonna be on the previous week's lecture notes. So not like the previous day or the previous lecture, it'll be the previous week. Okay, I'm gonna give it at the beginning of class. So if you're late, if you don't come to class on that day, there's no makeups whatsoever. While I don't take attendance, because for the most part you're all adults, right? I'm not gonna baby you, I'm not gonna require you to be here. But at the end of the day, like if you're not here for the quiz, you're gonna get a 0 on it. And that constitutes half of your grade, right? Like there's 10 of them, and if you miss one of them, you can do the math of how much percentage that is out of your final grade, right? So that's that. You're gonna have assignments. They're gonna be online and in class. So be sure to actually show up for that, and you're gonna turn them in. They'll have specific due dates. I believe there's like 5 of those. You're gonna keep a lab project notebook. So this is in regards to the actual ukulele. I want you to keep notes of what you're doing, and I'm gonna periodically, I think like 4 times in the semester, ask you to turn them in, and I'll be looking at them. I won't be grading them on specific content, but obviously if you're just doodling like something totally irrelevant, you're not gonna get points on it. But if you're doing something very specific to the project, then you're gonna get full credit on that notebook. And then at the very end, you're gonna have a group project report. You used to have to present, but last time I taught this class, the presentations were pretty routine and the same, right? You all are doing a ukulele, you're all doing the same thing. So to kind of prevent that, I'm basically just taking it out of the class. But you have to have a report at the very end of it. Okay, so that's the breakdown. So, I mean, half your grade. There's no tests, so that's good. I'm not a really big fan of tests because I think some people just aren't good test takers. The quizzes will basically be that. So it's less content per quiz than like what an exam be, but it's still, a quiz. So you still have to be on your toes. And here's the breakdown if you want an A, A-, B+, or if you want to just pass, then that would be a C- that you gotta get. right? That's the bare minimum to get credit for this class. Okay, so you don't have to read the paragraph here, but I would on your own time. The one key thing I want to mention here is that as you're going to learn next week, learning in general is an active process. So when I was a student, I would just sit down and take notes, and sometimes I forget, what did I just write? Like, you know, you're just like this machine that's just like taking notes and just copying whatever from the board, right? And I would realize like, oh my goodness, what the heck did I just learn? I have these equations, I have all this stuff on my notebook, but I have no idea what he just said or she just said, right? And so it's an active process, and it requires multiple iterations of you hearing something and learning it a different way, seeing it differently, for you to actually grasp it. And I'm bringing this up now because ECE 101, I'm making it more technical, so we're gonna have equations, we're gonna have to solve them, we're gonna have to, you know, get dirty with our hands. But I think it's going to serve you well later on. Engineering curriculum in general is really hard, and I'm not trying to discourage you from it, right? I'm not saying like you can't do it. You can all do it. It's just a matter of the time you put in and how much you really want it, right? For some, it's going to be easier in terms of like how much time you have to put in, not easy. And for others, it's going to be really hard because you're behind on like the math or whatever. That's fine, but you can still accomplish it. I have yet to see a student. I have one student. I won't say his name. He started here at CSUN. He hadn't even passed algebra. You would think, wow, that's not an engineer, right? He took algebra here. He took trigonometry here. He took pre-calculus here. Took calculus 1 here. He started off behind, right? It took him a while, but he graduated last semester with an electrical engineering degree. So it's possible. So if you're in that scenario, don't. It might take you a while. Might take you longer, but it's still possible, and don't kind of give up on that dream if you want to do it. But this class is supposed to be a primer for you in your electrical engineering curriculum. So that's what I'm hoping you kind of get out of this. So when you get out of here, I want you to not only just take notes, I want you to actually like challenge yourself with different problems, even if the professor doesn't assign them to you, and those kind of things. So don't be afraid to fail. Failing is like the best thing you can do in a non like bad way. So what I mean that is like, if you fail on a quiz, it's gonna hurt your grade. If you fail on a worksheet in class, that's fine. If you're not graded on it, that's fine, right? It's good to fail. Don't be afraid of that. Okay, so here's like specifics about the actual quizzes. Take a look at it, read it on your own. But there's 10 quizzes, there's 5 assignments, and there's 4 notebook submissions, if you want the numbers. Here's the ukulele project. So you're gonna be given that kit basically over there. I have to put the order in, but we do have the money already. And then I'm gonna give you one of these cigar boxes. You're gonna get to choose, and then we're gonna basically make the speaker for the ukulele. And anyone curious, like, and at this point, does anyone kind of have an idea or a questioning, like, how are you going to get something that is making sound waves and make it into a signal that a speaker can output? Is that not even like, is that kind of going in your mind right now or not really? Yeah? Anyone want to take a little guess at how it works? Yeah.
Maybe like a little mic inside?
That's a good one. That's true, you can do that, yeah. But that wouldn't be so fun, right?
Yeah, it wouldn't be like
That's kind of cheating, isn't it?
Yeah. Don't usual electrical instruments have like a pickup?
Yeah, what's a pickup?
It's pretty much like, or an instrument, it's kind of like, it picks up the vibration of the strings.
Okay, yeah. Oh yeah, and your name is? So I'm gonna ask your names, and it's not because I'm being weird. I just want to get to know your names. By the end of the semester, I like to pride myself on knowing everyone's name. So your name? Abraham. Yeah. There's a thing called a pickup. So why am I asking this? You're probably like, why? Why do I care? Right? We're just gonna do it, right? Well, no. This is part of being an engineer, right? Is like we see things as black boxes usually, right? As like consumers of like a speaker or a ukulele. We see it as like, oh, this thing's already built. I'm gonna play it or I'm gonna use it, right? As an engineer, you want to take things apart and actually start learning about them, right? And so when I ask the question like, well, what's going to cause you to get a sound wave, which is it's a sound wave, right? You're basically vibrating something like strings, and you hear it. How do you actually make it into a signal or something that can be output by a speaker? Well, a speaker is like this thing that also vibrates, but it's getting a signal that's making it vibrate, right? And we're going to learn that it's an electrical signal, right? And so at some point you have to get the sound signal, turn it into an electrical signal, and the speaker turns it back into a sound signal, right? So this process of like converting the signal into different forms is really what engineering is about. If you're a mechanical engineer, you're just basically moving around objects, right? Whether it be with gears or with tires or whatever. Electrical engineers move things with electricity, right? And so we're gonna learn that later on. Pickup coil, we're gonna learn, is basically just wire around a semi-magnet. And it's kind of crazy how that works because usually the strings are magnetic or steel, and there's this force that's kind of emanating from these steel wires that are magnetic fields, and they're interacting with the magnetic fields of the pickup coil. And that interaction then gets transduced or gets made into an actual electrical current, which you can then manipulate. So we'll get to all that stuff later on, but that's kind of what you guys are going to use is what's called a piezoelectric. So it's a little fancier, but it is a little easier to use. So we'll get to that later as well. Okay, I have a slide on accommodations. So if you need more time on a quiz because maybe you have some anxiety or you have some other issues that that's perfectly fine. So for the quizzes, for instance, if you need more time, I would just say go to the DRES office, so it's Disability Resources and Education Services. And once you get cleared that you need more time, if it's a condition that keeps you from basically doing with the quiz within a certain amount of time, then that's fine. You can either take it there or take it here, and you'll be given more time. But just make sure you have to have that clear. There's a whole process. You have to go through that office. They email me. I accept it, and I usually will if they're trained professionals. I don't have any expertise in that, so they'll tell me, and then I'll approve it, and we'll then accommodate you as need be. So this could be like you need more time, if you have like vision problems or hearing problems. Even me recording this, if you need like closed captions, I'll try to close caption them, but I'll also, that also needs to be also mentioned to DRES as well. So I have to be aware of it, basically, right? So yeah, that's the office to go to. Okay, and here's just a look at the class schedule. I won't go into too much detail, but this is kind of how we're gonna run our lectures for the next couple of weeks here. Okay? Any questions? It's gotta be questions. Yeah.
What software?
Yeah, great question. So as you see that there's like, for some of you that don't have the monitors out, there's actually a monitor that's hidden beneath these little things here. So the software you're gonna need in this class is gonna be PSpice, MATLAB, and then there's gonna be a thing called Tinkercad, which is an online software tool. We'll get to that a little bit later, but we're gonna teach you how to use these software, which I think is pretty great because usually this is a scenario that I've seen students in. So I teach other classes like EC 240, 350, and if they require MATLAB or PSpice or anything like that, students, that's the first time they actually use that software. And there's just a large learning curve. Like it just takes forever for them to learn even how to open the thing, right? So the good thing in this class is we're gonna do that right away. So that when you get to 240 or 350, you're gonna already know how to use it basically. So those are the three main ones we're gonna use. The Tinkercad is gonna be basically to have like an online breadboard that you can make a circuit on and simulator on there as well. So yeah, good question. We'll get to all that, what all that software does and what it means later on. Class structure. So this is the general breakdown, but it's gonna depend on what we're doing that day. But generally, we'll do a lecture activities for the first couple of minutes, like 50 minutes, and we'll give you a break because me talking on can be a little bit tiring for all of us. And then we'll do again lecture lab activities until like 10:45ish. Okay. Any questions? Okay, so my goals for you in this class. By the way, can you turn down the lights over there? I think it's kind of bright. Maybe some of you can't. Can you read this, or are you just fine? You just turn one of them off. Yeah, that's good. That's better, I think. So my first goal for you is to prepare you for college and its rigor. I already mentioned this. College is hard. You'll get better at it as time goes on, but it's not easy. Give you the confidence to work on closed form engineering problems. So I use that wording specifically because closed form means like you can actually solve it using like algebra or calculus. There are other things called like open form, which means like you have to use other methods to do that, and that's for like later on in your curriculum when you're like seniors or even graduate students. But the goal here is to get you guys to basically not be afraid to work out problems. That's going to be a lot of your like classes in this here at CSUN is working out problems, problem solving, and finding a way to figure out what the final answer is. Okay. I also want to provide you hands-on opportunities. So my goal here is to give you specific skills. So like for instance, I want you to know how to use PSpice, right? I think being able to put a resistor and a battery on PSpice and simulating, we'll get to what simulating means. Like basically figuring out if the solution to the problem that you have, if you can verify it with PSpice. This is a software that allows you to verify problems that you're working on. It's a really good tool because when you're doing a lot of problems like for ECE 240 and you have the answer and the professor is being a jerk and doesn't want to give you the answers or they're not in the book, you can actually use PSpice to validate what you've done or to invalidate if you got the wrong answer. So it's a good tool to have, it's a good tool to use, and you even use it when you're actually out of school if you're doing electrical engineering work. But also things like soldering. Who's ever soldered? Who knows what soldering is? Okay, some of you, that's quite a bit amount. Soldering is like making a joint for electrical connections, right? It's gonna be a little dangerous. We have a soldering iron over there, but we'll be careful, and you're gonna learn how to do it. Who also knows what a breadboard is? Yeah. So a breadboard is basically like a prototyping board that allows you to prototype a circuit board. So a circuit, it's basically a closed loop little system that allows for electricity to kind of flow. So you can turn on a light bulb, you can turn on LEDs, do all that kind of stuff, and we're going to use a breadboard to do that. So why do I care? Because in ECE 240, which is what's considered a high failure rate class, you have to use a breadboard. And a lot of students don't know how to use breadboards until they get to that class, and they have to learn it right away. Now you think about that, like you actually have theoretical concepts to grasp at that time, plus you have to learn how to use a breadboard. That can be quite a bit to learn at once. So learning how to use a breadboard now is going to be really important. And you're going to find out that I am a stickler for that. So like, I'm going to give you all these exercises. Put this on a breadboard, put this on a breadboard, put this on a breadboard. And you're going to get so annoyed with breadboards that you're going to be so good at it when you're out of here. Even if you're not good at it getting out of here, you're going to be a lot better than people that are barely learning how to use it. So that's what I'm going to provide to you. And also to help you embrace your inner nerd, because it's just fun to be a nerd. I don't know. All right, any questions? You can impress people with random things. Okay. Okay, so about myself. So you're probably wondering, who is this guy? So I'm actually, this is my 4th year here at CSUN. I just finished my 4th year, so I guess we're gonna be finishing my 5th year after this year. So I'm actually a biomedical engineer by training. But my undergraduate degree, we had to emphasize in a core engineering field, which I did electrical engineering. So I have a lot of electrical engineering classes under my belt. So before here, so I've been here quite a while now, I think. I did my BS at USC, and it's biomedical and electrical engineering emphasis. So half my classes were electrical engineering. And then I went to UCLA because I'm a trader, and I did biomedical engineering there. And I got my PhD there, and then I went to Connecticut. Who knows where Connecticut is? On that, it's all across the country. Yeah, and I did what's called like a postdoc. It's like after your PhD, and I did that at Yale in Connecticut, and it's really cold over there. Who's ever been to the East Coast? Yeah, where have you guys been? Just out of curiosity. Yeah. Chicago. Okay, that's like Midwest, but yeah, it's cold, really cold there. You were there this summer? Okay, so it's probably humid, right? Okay. How about, you said you've been to the East Coast?
The one that got away was from Brooklyn.
Oh, okay, Brooklyn. You? Abraham, right? So your name was, sorry? Sean, and then your name? Jacques?
Yes.
Okay. Yes, Abraham.
Washington, Brooklyn.
DC, okay.
Washington, DC, Brooklyn. Chicago.
Chicago. Yeah, if for those, so I'm guessing a lot of you are Californians. Yeah. So if you ever have a chance to just visit somewhere, I know it's expensive. It's expensive. You know, I wouldn't come home because the flight was horrible. But what I recommend is, yeah, take a trip out to a different part of the country. I prefer the East Coast. It's a little cooler over there. It's kind of like California, just everyone's a little bit more on edge. But yeah, it's fun. It's different to see some places that are not California. So then I came back and I'm at CSUN. So I also did an internship when I was an undergrad at Medtronic. Who's ever heard of Medtronic? Yeah, do you know what they do?
No, but my cousin's my cousin's boyfriend, he works there.
He works there? Okay.
It's across the street.
The one here, yeah, huh?
Yeah.
I was medical 10 years, so I used a lot of Medtronic.
Okay.
12.
Okay, yeah. So they work on medical devices and medical technology. They have different sites. The site here in the site here in basically Southern California, they have a couple, but one of them here is in Northridge. They actually work on glucose sensors. Who knows what a glucose sensor is? Who knows what glucose is in general? Yeah, what is glucose? Sugar. Yeah. So when we eat food, right, we have to break it down into actual energy for our cells, right? And so some people have diabetes, so they basically cannot process the glucose, and basically the molecule called insulin is supposed to be able to help you process it, but it can't. And so they have to have an external system to help regulate their sugar levels. And so Medtronic here, they actually work on both those things. They work on the sensor that senses the blood sugar in your body, and then it has also a pump that's basically an insulin pump that allows you to regulate the glucose in your body by injecting you with insulin. So I worked there for a little bit, working on sensors for about a year. Yeah. So I have some experience with like grad school, obviously, internships, working for a company, what it's like. I'm not trying to brag. I'm just trying to tell you that if you have questions on these kind of things, you can ask me, right? You can ask me like, how do you apply to grad school? What is grad school like? How do you choose a PhD advisor? How do you choose a master's program? How do you deal with like really, really stressful industry bosses, right? Or what is it even like working for an industry, right? That kind of stuff. Or I even have people that work at these places that can help you navigate through them as well. Because once you're an academic, you know, you're out of it for a while and you're just like, you know, you don't know all of it, obviously. But I can also point you in the direction of people that have worked there for quite a while. Okay, so that's about me. So a little bit more about me because I like to brag. Just kidding, I don't. I really don't. So what do I teach? This is probably what you're curious about. So I teach 101. I teach ECE 240, though I haven't taught that class in a while, and I'll get to that later on in the next little part of the slide. ECE 280, so that's like differential equations. ECE 350. I do senior design as well. You'll get to know what senior design is, but I do have some groups that I basically mentor. I also teach the biomedical classes, so Introduction to Biomedical Engineering and Bioinstrumentation. These are graduate level classes, the bottom ones here, but undergrads can take them as well. I also teach 602 and 602, but those are strictly graduate level classes that are not for undergrads. So what do I work on here? So along with teaching, you know, it'd be nice if I just taught, but I actually do like doing research and staying engaged. So I have 3 projects that I work on the side. The first one here I have some funding for, so I have basically I just need money to work on it. So this is for making a wireless powering system for implantable blood pumps. Who knows what blood pumps do? I know it's self-explanatory, but what do you think they're used for? Why would you need a blood pump? I mean, like, arteries clogged? Okay, that's a good one. That's a good, why would your arteries be clogged? Yeah. Or heart attack. Yeah. So if you have a heart attack, for whatever reason, it could be, so it's not just about how you eat, it could also be like a congenital problem. Congenital means like at birth. So you could be born with like a faulty heart, basically. And so these devices are basically, they're actual pumps. Who's ever seen an aquarium pump, like the little turbine pumps? Yeah, these are actually like those. Obviously just designed to be able to implant them. Implant means like put inside a person's body. while they're living and walking around. And so what I'm doing is the way they power them now, there's a cord that comes out, and that cord is a source of infection because outside world has bacteria, inside part of your body shouldn't have bacteria, or not all kinds of bacteria, and so bad bacteria can get in there and basically infect the person, and they can die of infection even though they're doing okay with like their cardiovascular system. So I work on that. I actually have had a senior design group work on that. I actually have a blood pump in the lab downstairs, which is made by what's a company called Jarvik. So you can actually see how that works. The other one I do is this thing called wave intensity. It's just like MATLAB and signal processing. It's like how do we predict heart failure in some population of patients. And then I also do like this magnetic sensor for cardiovascular imaging. I'll say imaging because it's more like mapping the activity of your heart. Yeah.
For your wave intensity signal analysis, does that like involve like the PQRST segments and like how that?
Yeah, good question. It does involve it, but it's not the main like contributor to the analysis. It's more like of a marker to figure out where your heart's contracting. But yes, this is actually, so on that point, it actually uses like pressure waveforms, so pressure signals and flow signals from the arteries of your heart. And we use that to kind of figure out if someone's gonna get heart failure or not. So those are the things that work on. So like I bring it up now, you're probably wondering like, why do I care? Because I'm a freshman, I barely know how to do. So I mean, if you want some experience, I am taking in people to like help on projects. Now that's I'm not gonna give you the project like, hey, I want you to figure out how to actually map the cardiovascular system. No, it's gonna be like little mini projects here and there that I know you're capable of doing. That'll help me out. I bring it up now too because I'm recruiting, which is always a good thing. To have help is always good. But for you personally, it's experience, right? If you get experience early on in class and outside of class, you can put that on your resume. And if you really like the project and you work under, these projects for your whole entire time here at CSUN, that's something you can say, hey, I've worked on, wave intensity analysis for Dr. Valdovinos for like four years that I was at CSUN. So I know how to use MATLAB. I know how to do all this stuff. I know how to work with pressure waveforms, all this stuff. And when you apply for an actual like job, if it's even relevant to what they do, then they're gonna see that and they're gonna see that you're committed to doing something. So that's why I put it up there. Always be on the lookout for opportunities to like increase your hands-on experience and that kind of stuff. Okay, enough about me because I really don't like talk about myself. Okay, so I mentioned already we're gonna record our lectures. I said with CSUN Zoom, but I actually like Camtasia better. It doesn't matter to you. It's gonna be a video online, right? It's gonna be a video online, hopefully better quality. We're also gonna use apps in this class. So I'm gonna use Poll Everywhere. So it's gonna be kind of a rarity in your time here at CSUN. I actually don't mind if you use your phone, specifically when you're basically doing like an app here, like doing Poll Everywhere. If you're gonna be on your phone doing Instagram or whatever, I don't care. You're an adult, but be respectful. I don't want to hear your conversations. I don't want to know, right? If it's distracting to the class, I will throw you out. But I'm not a micromanager. I'm not a teacher from like high school. So if you're doing that on the side, I don't care. I don't get offended by it. I'm not that important. But at the end of the day too, don't be distracting. You're gonna find that if you cheat or distract the class on purpose, I get really angry and I throw you out. So it's hardly ever happened, but just don't do it, right? But we're gonna use Poll Everywhere. It's to basically participate. I say be respectful because there are times where I'm gonna have like a word cloud. I'm gonna ask you a question and you can put in like a word like, oh, like I'm gonna ask you, what are you looking forward to here at CSUN? Use one word. You can say, oh, partying, or oh, studying, right? Be respectful because it's gonna display on the screen, right? I don't want any weird words or whatever or weirdness going on up here that distracts from the class. Okay, so just be adults, be respectful. Pay attention to, because some of those questions, I actually might put them on your quiz, like the results, especially if they're like technical related, right? So I'm gonna ask you like things right now where it's like, oh, where are you from? What do you like to do? But I might even ask like, okay, here's a circuit. How many nodes are there? Or how many loops are there? And you might see that exact question on a quiz. So I think it's good to pay attention as well. You're all adults. Well, almost. I put a little thing there. So your prefrontal cortexes are not totally developed. Again, I'm a nerd. But that's true. So what that means also is I'm a little more understanding of because you're younger. So the one thing about coming in college is that we expect you guys to be adults, right? And for the most part, you are, but your brains are not totally there yet, right? Your prefrontal cortex is the big old part of your brain right in front here that is for decision making and things like that. And at this point, you guys are great, but it's not totally up to like adult level yet. And so like, if you guys screw up on something, if you, miss something, you can talk to me about it. I'm not gonna like lecture you on it. I'm not gonna, wipe my finger at you. But don't take advantage of that either. I know you guys are full functioning adults pretty much. So, don't think that you're gonna go with everything. All right, so are there any questions now? Because I'm about to get to poll everywhere questions. So who has a smartphone or some device they can go online pretty quickly on? Okay, so you can do that. You can also text to it, but I think it's gonna charge you. Yeah.
Is there an app for it?
Probably, but you're gonna see like a little link up there, which you can type in a second. If you don't have it, that's fine. Again, it's not an attendance thing. It's just more to get participation. Okay, here's my corny little like slide about what this, and it's kind of cutting off because I have to fix the light. But kind of the motto in this class is like minds on and hands on. So hands on is great, right? You're gonna learn how to actually use your hands and do things that are useful, that engineers do. But also we can't forget like you also have to use your head when you're actually like soldering or building a breadboard, like a breadboard circuit. So we're gonna mix in like theory and also hands-on activities. So that's gonna be the model for this class. Okay, so before we do the poll everywhere thing, I do like to go around and get you guys to actually talk. So what I want you to do is I'm gonna start over here, and you can stand or not. You can just sit if you want. And I want you to basically say your name and your major, and what's one thing you're looking forward to here at Easton. So we'll start with you.
I'm Josh Kepp. My major is electrical engineering, and I'm looking forward to meeting.
Thank you, Josh.
My name is Danny. I'm an electrical engineer as well. I'm looking forward to just meeting people and like having a good time, like getting work.
Okay.
Hey, my name is Gates Martinez. I'm also studying electrical engineering. We want to have a good time.
Okay.
My name is Elizabeth. I'm an electrical engineering major, and I'm looking forward to general college life.
My name is Abram David, and my major is electrical engineering, and I'm looking forward to exploring the campus.
Okay. Over here.
My name is Eric. My major is also electrical engineering, and I'm looking forward to my FAFSA money.
Okay. Yeah.
Kyle, also electrical engineering, and I'm looking forward to graduating.
I'm Jane. My major is electrical engineering, and I'm just looking forward to having students.
I am Sako, and I'm majoring in electrical engineering, and I'm looking forward to finding opportunities to take connections.
I'm Pujan, and going to electrical engineering. I'm here to get more experience and get graduated.
I'm Daniel. Obviously, electrical engineering. I'm just looking forward to getting my degree.
Job, electrical engineering. Looking forward to finding that work.
My name's Sean. I'm a psychology student, and I'm here to try and learn some more about electrical engineering. I'm the founder of Nano Robotics. I'm part of the CSUN Innovation Incubator Lab. I'm trying to get a biomedical device approved for senior design, and I want to recruit all of you and invite you to try and come to the senior design. And you as well, Professor, I would like to recruit you for the project.
Okay.
My name is Adi Joseph. I'm from Noah. My major is electrical engineering too, and I want more experience in terms of snack activity, like what you the board you said, the board.
A breadboard, yep.
Yeah, I want us to understand everything.
Okay.
My name is Mark Valentino. My major is electrical engineering, and what I'm looking forward to is learn and work on.
My name is Jose Cabrera. My major is electrical engineering, and I'm looking forward to learning things.
My name is Juan Ramirez, electrical engineering major, and I'm looking forward to meeting new people and to gain knowledge.
I'm my friend. I'm majoring in electrical engineering, and I'm looking forward to learning more.
My name is Kevin Lopez. I major in electrical engineering and I'm looking forward to graduating.
My name is Wenceslao Santa Cruz. My major is electrical engineering. I'm looking forward to being with people.
My name is Cesar Ortiz. My major is electrical engineering and I'm looking forward to exploring clubs.
Okay, cool.
My name is Kevin Cortez. My major is electrical engineering and I'm looking for overall experience.
My name is Carlos Fuentes. My major is electrical engineering and I want to learn more about this major.
My name is Gaurav Masarlian. My major is electrical engineering and I'm looking forward to meeting new people and learning more about my major.
My name is Aaron. I'm an electrical engineering major and I'm looking forward to learning some interesting things.
My name is Christian. My major is electrical engineering and I'm here to go my time here at CSUN and to study electrical engineering to work on
Okay.
Well, my name is Abraham, electrical engineering major, and I'm looking forward to getting to know more people and looking forward to understanding more about the electrical engineering field.
Cool. Those are all good answers. All right, so pull out your poll everywhere. So here's the thing. You gotta go on. Let me close this. So bear with me here. Okay, so the first question I'm gonna ask, and we're gonna activate it. So what you're gonna do is you're gonna go on the web. Why is it not showing? Oh, you know why? It's on the wrong screen. There we go. Why it's so big? All right, here we go. So the first setback of technology here. Let's see. I literally just got this screen, this thing. Let's see. We're gonna go here. Let me just put it on the board here. Let me. You're gonna. It's kind of big, but. Come on. Okay, for some reason it's. Did you guys see? Did you guys already see it?
Yeah.
People are already answering. How did you guys see it? Was it showing?
They already has a .com thing. All you have to do is put your name and then the number.
Oh, okay. Well, like I said, so it's gonna be fun to figure this out. So like I said, it's my first time recording with this thing here, and for some reason it's not here. All right, I'm just gonna read to you, and I'll show you. So the first question was, what city and state are you from? I'll figure out how to post it. It's for some reason it's like magnifying the thing. And people put Northridge, Compton, Palmdale, Santa Ana, Granada Hills, Santa Clarita, Panorama City. I'm thinking Bell Gardens, but separated Bell and Gardens. But it'll show that. We'll take a break right now anyways to do that. So a lot of you are from here, right? Is kind of my guess from that. And it'll show up it'll populate here. So actually it's still kind of good time because it's 9:50 already. Let's take a 10-minute break and then we'll finish with the next couple of questions while I basically troubleshoot pull everywhere. All right, so come back at, according to that clock, 59 or 10. Right, so I'm gonna pause the recording as well. So we're gonna go on break. All right, let's get started again. So here we go. I just fixed the settings, obviously. All right, so this is where you all said you're from. So pretty much everywhere. I actually am from Azusa, so I live really far. Who's from the San Gabriel Valley? Nobody. Yeah. Does anyone know where Pasadena is? Yeah, I'm like another 15 miles east of that. So, yeah, it's rough. That's okay. So the next question I have is what are you most looking forward to in your time at CSUN? So for those of you that, I guess, because I couldn't post it, you can go on pollev.com and then you can /John Baldwin and then 647. Or you can text to that, but all data rates apply, yada, yada, yada. So, yeah, so once you start giving answers, it'll start populating.
It's not like updated. Yeah.
It's not updating? Oh, you know why? There you go. That's why. There you go. Yeah. Told you. It's gonna be some rough patches with this, but it's all for the good for you. You guys can see these videos later on. I highly recommend replaying videos. Who listens to podcasts? Yeah. Have you ever played like double speed or slow speed? It's hilarious. So I definitely recommend you double speed this up. See how I sound. If I sound like a chipmunk or the new experiences, making connections, learning, meeting new people, and graduating. Yeah, graduating is an important thing here. And so no one's saying meet new professors. That's sad. No one cares about this. All right. So I'll go to the next one. Kind of keep things moving along. I'll activate that one as well. So what are you most nervous about in your time at CSUN? Just like, so by the way, it's anonymous, so I don't know who puts what. I'm not encouraging you to put weird things, but just letting you know that if you have something that really is worrying you, then you can. So failing, keeping up my studies, meeting people. Let it open a little more. Passing. Well, that's making you nervous. Passing all your classes. Oh, maybe not passing your classes. Yeah, that might be not networking enough, not passing classes, failing. Yeah, so that's what I was saying earlier. Like you guys. So this is the thing. You shouldn't be afraid of failing, like on your homeworks, on your tests, on your non-graded tests. So some professors do give you access to like a previous semester's test, or if you could actually have someone, some of the professors, not you though, had heart. Thank you. I already feel loved. That's all I really want in life, just for you to love me. You're supposed to laugh. Okay. Anyways, not keeping up. So yeah, that's another one. The keeping up, it can feel like it's draining. So I always tell this story, and my wife hates it because she hates being called out. But my wife, she's actually a psychology major, like Sean. She double majored in Spanish and psychology, and she was when I first met her, she was crying. She was crying because she was looking at all her syllabi from her classes, and I was like, "Why are you crying?" And she's like, "Well, because I have so many things to do." And I was the opposite. And this is probably why I failed my first test, right? Because I was like, I'll figure it out. And I'm smart. I know how to do this, right? No, she didn't. She didn't fail anything. She got straight A's. She got, I think, 1 A minus. But every semester she would cry, look at her syllabus. Why am I saying this? Because for some of you, it may be overwhelming, right? Like, for some of you, maybe like me, like, oh, whatever, I'll get it done at some point. For some of you, it might be like, I have so much stuff to do, I don't even know how I'm going to find the time to do it. And it's okay to feel that way, right? Because it is a lot of work. You're going to get to some of your GE classes, they're going to probably have you reading like, I don't know how many hundreds of pages in 1 week. You're going to have these classes are going to give you like 25 problems per week. And they're going to be hard. So it's going to be tough, right? My point in all in saying this is that it's okay to feel that way, but you have a lot of resources. We'll get to those resources that you have here. You have a lot of tutoring available. Your peers that are, if you meet some older students that have gone to the classes, they're also a good source of advice and also just like past exams to practice with. If there's one thing I want you to remember from today's class is that you should practice those problems. So if you're taking like a ECE 240 class or ECE 350 class, try to get as many problems done as possible in your time. So you can figure out the different ways that professor can ask a certain question and understand those concepts. That's going to be your best friend, is basically just leaving no stone unturned in terms of like passing the classes, and make sure that you understand them. And don't be afraid to fail on those problems because those are the ones you're not graded on, right? It's the exam ones that are graded on. So professor not connecting with me. Yeah, and look, I'm gonna be honest. A lot of us don't connect, right? Whether it be different cultures, different age, all that stuff is gonna be difficult. But do know that most of us do care a lot about the students, right? Like we care about your success here. Because if not, then like we're just pushing out a bunch of students that aren't good at what they do, right? And that's not good for the way we look as well as a college. So yeah, but with that said, that's a good one because I want to bring up go to office hours. No matter how intimidating a professor may seem, go to office hours. Ask him or her about the class. Get him engaged. Ask them. Look, people like to talk about themselves, right? On a very human level. So talk to them. Ask them about what they do for research. If they do research, that kind of stuff, and that'll get them engaged. And usually, you make a lot of good friends with the professors, because they're the ones that are going to help you succeed. All right, off my soapbox again. All right, so the next one I'm going to ask is use one word to describe why you want to study engineering. So I'm going to activate it. Go ahead. It could be, money. Could be prestige. I don't know. Oh, there it is. Yeah, I knew it. Hands-on, change the world. So if you put like two words, it might like separate them. Just kind of word of warning, obviously. Fascination, yeah. Money is a big one. Dollar signs, electronics, cash. Yeah. Okay. So cash. It does bring cash, especially depending on where you work. We'll get to like some salaries later on. You're probably curious about that. But like to give you an example, some engineers, depending on the company, if they're big companies, you can basically make on the order starting salary like $75,000 a year. That's not a lot, but it is a good starting salary, and you jump up pretty quickly as you're in there. If you have a higher degree like a master's and you're doing like a research and development group, they can make like $90,000 a year and higher. So yeah, you have a lot of money doing this. More money means more responsibility typically as well. So it doesn't come without its price, literally. Hands-on, money, dinero. Okay, you all love money. Yeah. Hopefully that's not the only motivating factor, because that gets, so there's been a study, I forget what study it was, but there's a study probably by Harvard or whatever that showed that like after a certain amount of money you make, you're not any happier for the most part on average. I'm sure there's some people that make a lot of money that are really, really happy, but it should be the only thing. I say that because it's gonna be so rigorous with the courses that if money is the only motivator, that might not be enough. But hopefully we have some other ones as well. Changing the world is a good one. That certainly keeps you up at night to help. All right, the next one is, I think you already said this. You don't have to do this one. What's your currently listed? I'll go to the next one. A lot of you already said your electrical or computer. Why isn't it going? All right, so that's it for now because I think I've exhausted the ones for today. So let's go to the next slide. Oh, you don't want this. All right. Okay, so what I'll do now is just get started on the next lecture, or the next part of the lecture. Oh, look, it's recording me. Oh, it closed captions, great. It's recording me on the bottom. That's awesome. Okay. So I know it's kind of, I'm gonna have to change that. But engineering at CSUN. So this is probably your first time here. So for how many of you is this your first time on campus? Okay. You probably have had some issues with parking already, right? Parking can get pretty hairy here pretty quickly. So try to get here on time because you might miss class. So engineering here. So we have multiple departments here. So most of you are in electrical and computer engineering. But some of you may consider switching if you are just finding different interests. But this is our college website. We have 5 different departments. We have civil engineering and construction management. We have computer science, electrical and computer engineering, mechanical engineering, and manufacturing systems engineering. So those are the 5 different departments we have here. You are in electrical. and we'll get to that in a second. So if you have any questions about engineering, the website to go to is basically csun.edu/engineering/computer/science. So that's like all about the dean, all about the different departments, the history, the different resources as well. You'll find them on the column on the left. So ECE and computer engineering. So we are located in the 4th floor of JD of Jacaranda Hall. That's up here. If you go up the stairs to the 4th floor, so go up 2 flights of stairs, and then you make another left, and we're kind of towards the elevator again as well. On the right side, you're gonna find the electrical engineering department, and then you're gonna have there's 3 administrators there. One of them who's really important is Javier. He is the department manager. He basically manages everything, keeps all professors in line in terms of like keeping up with like our class schedules and all that kind of stuff. He keeps it together. In that office, there's also the department chair, who's Sembian Rengarajan. You might be seeing him if you're doing like senior design or any kind of advising later on as a junior or a senior. You'll see him later on as well. This is our website, and this is the place that you should probably bookmark on your like Firefox or whatever browsing explorer you use. Because this is gonna have all the information about like your degree, and so we're gonna get to on Wednesday. I don't want to get to it today because it's a lot, so I'll probably cut it off short today. Is basically what do you need to do to graduate? A lot of you put on your poll everywhere that you want to graduate, right? Looking forward to that already. You just started, but the important thing is to keep track of how you're gonna get there, right? It's one thing to say it; it's another thing to figure out how the heck do I get from point A to point B. The good thing is that this website has a bunch of tabs and pages to help you do that. The bad part is it's a lot of information, right? You have certain requirements to fill, and we'll get to those on Wednesday. We're gonna actually do our first like little mini lab where you're gonna open up the computers and you're actually gonna look at what a degree progress report is. You're gonna look at how to actually plan for your graduation the next couple of years. Just out of curiosity, like kind of old school, raise your hands. How many of you would like to graduate in 4 years? For those of you that want to do that, how many of you think it's actually feasible in terms of like where you are now, like where you're standing? No one? Come on, you guys can do it. Yeah, it's not easy. Even if you have everything laid out, it's not easy to graduate before, because things like impacted classes come up and those kind of things. If you maybe even fail a class, that stuff can also deter you. But this is the page you want to go on to basically find all of your requirements. And I'll go over one more page and then we'll call it a day. So, electrical engineering, we offer a bachelor's in computer and electrical engineering, so 2 separate degrees in it. Basically, computer engineering is just like computer science, except that you're learning more hardware. That makes sense, right? Hardware being like computers, like digital logic, how do computers actually work and make decisions, that kind of stuff. Electrical engineering is a little more broad. We also offer a master's of science in both of those different fields. So on the very bottom here on the left, you'll see that there's like different emphasis. So what does that mean? So electrical engineering is a really big field, right? Like electrical engineers don't just do one thing, right? We don't just look at circuit boards and that's it. They actually do different types of applications. So for instance, we do biomedical engineering. So you can actually work on electronics or computers for biomedical engineering technology. There's also communication systems engineering. Who knows what they do? Any guesses? Yeah. Okay, that's more like biomedical. Yeah, but you're close.
Telecommunications.
Yeah, telecommunications. So like spectrum, TV, all that kind of stuff. The engineers work on that. Also satellites, right? Space, NASA, think JPL. So you have to communicate with space structures, right? Like satellites and spaceships. And that requires you to know about communications theory and all that kind of stuff. Like how do you actually send a signal that is millions of miles away and then retrieve that back, right? So that requires communications. There's control systems engineers. What do you think they do? Like
write the programming code that controls the forces and all the sensors.
Right. So communications engineers, they actually work with whole systems. So you're gonna find that like biomedical and controls are probably the most interdisciplinary. What that means is they interact with a lot of different fields in engineering, not just like electrical engineers. So they actually work on how do you get a system being like a car, being a cochlear implant, anything that has multiple components and parts that need to work together for one common goal is gonna require a controls engineer. So that's what controls engineers do. So that's a very, what I'll call mathy field. Mathy being, you have to be able to model your system as a simplified system, predict what it's gonna do, and then control for any kind of like weird behavior that you might anticipate from that actual system, right? In the case of a car is a system, right? You have a driver, a user who's pushing the gas pedal and braking, right? There should be some safety kind of backups to keep from like the driver from like going out of control, right? And there are for the most part. Autonomous vehicles now, vehicles that basically just go on their own, that's all controls engineering. That is literally having a bunch of sensors, integrating actuators, integrating motors, all that stuff, and compiling a system or an algorithm that's able to detect when you're gonna get in a crash, when you gotta make a left turn, when you gotta make a right turn, and all that kind of stuff. So that's controls engineering. Digital systems design, so that is computer engineering pretty much. So that's working with like digital logic or working with analog circuits and how you make them digital. So that's like the ones and the zeros that you hear about a lot when you talk about electrical engineering. That is how do computers communicate with each other efficiently? How do you convert different systems of numbers so that a computer can actually make computations on that? So that's digital systems design. A vending machine uses digital systems. So like if you want to get Cheetos from the vending machine, there's a little microcontroller that's in there that's making these really complicated decisions based off of what numbers you push, what to vend, how much money you put in, how much money you have on your card. All that kind of stuff requires what's called a microcontroller. It's a really small chip or little system that basically allows you to make decisions based off what the user is inputting. So that's digital system design. You have electronics and solid state. That's a fancy way of saying you're designing circuits that are not digital, not ones and zeros. Like you want to amplify something, so like a speaker. How do you put in tone control, volume control? How do you filter out different frequencies? What does that even mean? That's all part of electronics. Then there's microwave and antenna engineering. So microwave, not in the sense of what you think, like the microwave. So there are engineers that make microwaves, design them. But microwave is more broad. What do you think it means in terms of the field and antenna engineering? I'll give you a hint. It's kind of related to communications. Yes. Yeah, waves. So what are waves? Yeah. No, you're right. So when things communicate, like when you're communicating with a satellite, right? There's the satellite, and then there's methods to actually send the signal you're sending. Microwave engineering, they actually work on the very specific part of that communication, the antennas. So you have a big old antenna, right, that can send information, and you have a big antenna that's capturing the information. So that is the design of those antennas. And there's a lot of physics behind it, a lot of Maxwell's equations. You'll learn those in ECE 370. Really complicated equations, but they're really useful because they allow you to basically communicate over long distances. So that's antenna engineering as well. That's a good one because a lot of people are actually afraid of microwave engineering because of the math. Another very mathy field is you have to work with Maxwell's equations, and things like you'll have like these things called Laplacians and cross products, and it looks scary. But once you get an intuition for it, not too bad. You make a lot of money in those fields because you can work for like Boeing, Northrop Grumman, all those companies that JPL. That pay a lot of money because you have a lot of good knowledge about that field. And the last one is electrical power systems. This is kind of self-explanatory, right? How do we get power to our buildings? You have the poles and the wires. Like, how exactly do those get transferred to the buildings? And how are they actually allocated to different buildings as well? So that's electrical power. That also involves like nowadays like electric vehicles, right? So like hybrids and electric vehicles as well. So how do you design a battery that can hold that much power and that much energy? How do you have one that is efficient? So that's also part of electrical and power systems. Any questions? So I'm actually going to end it here. because the next one is the next set of slides is basically talking about how do we graduate from here. And if any of those fields interest you, the good thing is that you don't have to decide just yet. You're only freshmen, so you're gonna take a set of required courses that basically get you to this point. And at the very end, like your last 2 years of college, you're gonna be able to pick and choose which courses from which fields you actually wanna emphasize in. So if you really care about like